All right. Yeah. So we'll be seeing some analytical questions here straight away. What is the area contained within -1 and +2 standard deviation of a normal curve? All of you, do you know how to find out the answer here?
Yeah, calculated just
easy, right? Easy method. So let me show one method here based on Minitab. The other methods also equally fine. Now hope all of you can see my Minitab screen, right?
Yeah.
So please go to the graph, probability distribution plot. And then you can go to view probability. Choose the standard normal. First of all, choose the normal. Q mean equal to 0. Standard deviation equal to 1. That means you are referring to standard normal distribution. Now you go to shaded area and you have to give the X values and you are expected to find out the area inside. That means the last one, middle area, right? And you have to give X value. X value, middle area. Now, what is your X1? What is the question?
-1.
Area between -1 and then
+2.
+2. That's all. Now everything is done. You don't have to break your head. Straight away you give OK. Minitab will show the area between the 2 points, -1 and +2. What is the area contained?
81.8.
If this 81.86 is there, then that will be the answer. So I'm
Sir, Siva sir.
Yes, sir.
Right from the beginning, you show me that.
I'll show it one more time. First of all, 81.85. Can you see the answer here?
Yeah.
Yes.
So this is the answer. So I'll show it one more time.
Yeah, I have the Minitab just from the start.
Sir, you can also share. You can also share. Do you like to share your screen right now?
No, sir.
Don't want, right?
Please,
okay.
I'll follow. Just
right.
you.
So I have shared the screen.
Yeah.
We need to go to graph.
In the Minitab, it is.
You guide me, sir. You guide me, sir. Where should I go here?
Graph number 1.
Then.
After graph, you have to go to the. Probability distribution plot. Okay.
Now I have to click.
Yes.
Now I have to choose
view probability.
Very good. Then I have to click.
Okay.
Okay. And now I have to choose normal here.
Yeah. Normal.
I must standardize the normal by choosing mean equal to 0, standard deviation equal to 1.
That is a thing you are giving, or
we have to give. We have to give. When I give mean equal to 0.
Yeah, any standard deviation, mean is 0 and standard deviation is 1. That is a standard. That's a thumb rule.
Then the normal distribution will be considered standard normal distribution.
Okay.
See, please note, we are not given the real problem. If you have read the question, you can understand this. It was not a real problem. What is the area between -1 and +2? That's a statistical problem. In order to work with the statistical problem, we need standard normal distribution. Now I go to shaded area. Now, which one I should choose here? The middle one, or left side, or right side, or which one I should use? Middle one. Area within means?
Yeah, middle one.
Middle one.
Yes.
Yeah.
And what is your X1 value? -1.
-1.
X2 value?
2.
In this manner, you can get area for anything. If I give 1.5, 2.5 also, without going through any confusion, Minitab will give the clarity, right? So in this case, -1 and +2. So -1 +2 I have given. I am giving OK. Now that has given me the answer.
Fantastic. Thank you.
So likewise, there are many features. You can one by one, you can master it. So now, yes. So this question, I hope all of you can now solve. The -1 can be any number, +2 can be any number. Now, hundreds of questions can be asked in this model. And all 100 questions you will be able to answer if you know how to use a particular feature in Minitab. All of you are with me on this?
Yes.
I bring the 2 this side, -1 this side. What will be the answer? 2 this side, I mean -2 this side, +1 this side. Now what will be the answer?
Same.
Beautiful. Right? It will be same answer.
Yes.
Excellent.
Yes.
Good understand.
Variation.
Now some, definitely some confusion can arise now. The final exam score of an institute has a mean score of 74. And an institution has an average score of 74. And the institution also has a standard deviation of 6.8. You all know the situation, right? An institution has an average score of 74 and standard deviation of 6.8. And the exam score follows a normal distribution because the exam score is a continuous data. It follows normal distribution. What is the distribution for the mean exam score of 50 students? Do you understand the last statement? One of you, can you explain me? What is the distribution for the mean exam score of 50 students?
Mean exam score is a 74. So 50 students.
50 students.
Distribution. For
Now, what is the what is the distribution of the mean exam score? Now, every point in this curve is an average. Am I right? First of all,
yes.
This is distribution of average. All of you understand? This is distribution of average. Every time I choose 50 students, 50 students together is a subgroup. If I randomly choose 50 students and calculate the average, it will be one of the star here. If I continuously monitor the average, how the average will move? That is what they are referring to. What is the distribution for the mean exam score of 50 students? So this distribution is called sampling distribution. Hope one of the class we have taught you. There are 3 types of distribution. One is population. Another one is
sampling.
Another one is sample. Third one is sampling.
What is the difference between sample and sample?
You choose 50 students and see the distribution. That is sample.
Sir, I will come. Can I
Yes,
come?
sir, please.
Sir, please note, distribution of all the items is population distribution. Clear?
Yes.
Distribution of selected items is sample distribution.
Right.
Right? And distribution of samples is the sampling distribution.
Now, distribution of sample means.
Okay?
Oh, distribution of sample mean among the
No.
population is
Sir, you are
sampling.
taking one item, no? One by one. In the first case, you are taking one by one item. Yes or no?
Yes.
All the items you are taking. Yes or no?
Yes.
In the second case, sample, you are taking only a few items or 10 items. Yes or no?
Yes. Sample population is clear. Sample. Yeah.
Will have a mean, will have a value. Yes or no?
Okay.
Mean value.
Yes.
The distribution of another sample also will have another value, mean value. Yes or no?
Yes.
Yes.
The distribution of all these mean values will follow a distribution. That is called sampling distribution.
Okay, I will give one more example. So all of you are thorough with the population, right? Population distribution. The school might have 1,000 students. All 1,000 students mark when you visualize, that is population distribution. Am I correct?
Correct. Correct.
And a class of 50 students is a sample. A class of 50 students is a sample.
Yeah.
Now, the 50 students mark, I am plotting a histogram and that will appear like this. That means every point here is a mark scored by every point here represents the mark scored by the student. Am I right?
Yes.
So this point will refer to the class average. This center point will refer to the class average.
Class average. Yeah.
The class which you have chosen as a sample. Now this distribution is the sample distribution. All of you understand?
Yes.
Population distribution also understood. Sample distribution also understood. Now in your school, there are 25 sections. How many sections? 25 sections.
25.
Every section will have an average mark. Am I right?
Yes.
Okay. Within group actually.
Wait. Now every section will have an average. Now how many averages possible now?
18 average.
So
25 averages are possible.
20. Yeah. 25.
Can you visualize the averages? Can you plot a histogram of the averages? Right? And that is called sampling distribution. How the average is moving up and down with respect to the various classes. Class 1 average is here. Class 2 average is slightly above. Do you understand? So the distribution of the averages is called sampling distribution. So what are we concerned about now? We are checking whether the average is under control in all the class. Am I correct?
Yes.
As a principal, You want to see to that every class is performing well, isn't it?
Yes, yes.
So you will now refer to the sampling distribution. If the sampling distribution is under control, the whole school is under control, right? And now, how can you represent? There are standard notations for representing any distribution. When I say n, it means normally distributed. N means normally distributed.
Normally, yes.
The left
Yeah.
side is the variable. The left side is the variable which you are visualizing, right? And after the n, you have two number. One number is the mean value, other number is the standard deviation. One number is the mean value, the other number is the standard deviation. Please note, for the population, the mean and standard deviation are called parameters. For the population, the mean is given a symbol called mu, standard deviation is given a symbol called sigma. When I say mu and sigma, I am referring to population parameters. All of you are with me?
Yes.
Yeah.
Now I take the sample. In sample, the mean is x bar. The standard deviation is represented as capital S. These are called statistics, not parameters. The mu and sigma, what is the name? Common name for mu and sigma? Parameters.
Okay.
Population parameters. But the common name for x bar and S, sample statistics.
Yeah.
Now, moving on to the sampling distribution. What will be the center point of the sampling distribution?
Mean.
X double bar.
X double bar. Yeah.
Because every point is an average. So
Hmm.
X double bar. And you can calculate standard deviation here also, which is called standard error of the mean. Do you notice the difference in the terminology, all of you?
Clear, sir. Clear.
When I say standard error of the mean, I am referring to sampling distribution. When I say sample standard deviation, I am referring to sample distribution. When I say parameter, I am referring to population. There are three groups possible always. Am I right?
Yeah.
Three distribution possible. Now, the distribution currently we are interested is which one? A or B or C or D? A represents a variable called x bar. Yes, we are also talking about x bar. Am I correct?
Yeah.
Because what is the distribution we are interested in? Sampling distribution. Because they are talking about mean exam score of 50 students.
50 students. Yeah.
And so the standard deviation of the group will be standard error of mean. Am I right?
Yes, sir.
Standard error of the mean can be calculated using a formula sigma divided by square root of n, where n is your subgroup size, where n is your subgroup size, and sigma is the available standard deviation. In this case, population standard deviation is available. Use the population standard deviation, calculate the sigma n, you will be able to get a value of standard error of mean. Now look at the four options. Definitely your answer is between A and B. Am I correct? Because there only x bar is represented. Am I correct?
Yeah.
When I say
Sir,
x,
yes, sir. Yes, sir.
A
No,
means
B.
A means what? Look at the standard deviation. How much it is?
6.8, sir.
6.8 means you are referring to population. Because it is given population standard deviation. Correct?
Oh,
So calculate the standard error of mean. That will be this one. So the right answer for this question is this. Little tough, but then you have to gain the clarity. All of you are with me on this question. Why the answer is 2. Later on you can try sigma by root of n. You will be able to see this 0.9617. Clear, all of you?
Yes.
What are the three distribution we spoke right now?
Population distribution.
Population,
Sampling.
sampling. What is the name of the population standard? The mean and standard deviation of the population are generally called as
Mu
Parameter.
parameters.
Population parameter.
And the mean and standard deviation of the sample is generally called as
Sample statistics.
Very good. Sample statistics. Then for the sampling distribution, the standard deviation is known as, what is the name?
Standard error of
Standard error of mean.
Standard error of mean. Please note, it is the standard error of mean that will help you to locate your confidence limits. Only if you know the standard error of mean, you can know the extreme values of the mean value. You just now calculated the mean. It doesn't mean that mean will happen. But definitely what is going to happen will be between the limits, confidence limits. In order to locate the confidence limit, you need to use standard error of the mean. So you will keep this in your side, and then, later on that will be helpful. All right. Shall we move on?
Yes, sir.
Now, next question. Now you will be able to understand this, right? A random variable is normally distributed with the mean 80 and standard deviation 2 is the distribution, where X is marks scored by the students in the mock test. What is the probability that his score will be between 75 and 85? All of you understand the question now? All of you vanished?
82.
Do you understand the question? I'm not asking the answer.
Yeah, 80. The mean and 2 is standard deviation.
N is deviation, N 80 to
See,
80.
what is X here? What is X here? Marks scored by the students.
Yes.
Marks scored by the student is expected to be normally distributed with a mean value of how much? 80.
80.
Standard deviation of how much? 2.
2.
Having said that, if you know this much, what is the chance for a student to score between 75 and 85? I don't want you to break your head in all these scenarios. What should you do? You should take the help of the tools. Tools are to help you. Please understand. Can you see Minitab here?
Yes, sir.
Yeah.
Yes. Please go to graph. Go to probability distribution plot.
Sir, shall I help you, sir?
Yeah. Tell me, sir. Then
View probability.
view probability. Okay.
And the standard deviation is mean is 80.
Very good. Look here. Now I am not putting 0. This is a real-time case. Mean is
80
80.
and the standard deviation is 2.
2.
Please note this distribution is not a standard normal distribution. This is the distribution of the marks scored by the student.
And click OK.
The real problem we are talking about right now. All right. And now we are going to the shaded area. And
Yes, sir.
I have
X
to
value.
choose
X
X
value.
value and middle.
75.
Very good. X value here is 75. X2
And,
value here
2
is
is
85. And Minitab should give me the answer. That's all. You don't worry. So what is the chance for a student to score
98.76%.
All of you, please note, we are also having, class average of 75 in our black belt batch. We are also maintaining a standard deviation of 2. That is the level of, standards we maintain. So what is the chance for all of you to score between 75 and 85?
98.76.
98.76.
So 98.76% chance is there for each one of you to score between 75 and 85. How are we coming out with this probability? Because we know the history. The average is how much? 80.
80.
Standard deviation is 2. If this is your history, this much chance is there for a student to score between 75 and 85. Hope it is clear to all of you. Am I right?
Yes, sir. When we start before, there was a question like standard deviation is high. Automatically, the curve will go very lean. Correct.
Standard deviation high means?
High means the
Dispersion is
curve,
high.
Variation is more.
No, sir,
Standard
less, sir,
deviation
very
high
less.
means variation will be more. Let me increase the standard
More.
deviation, right? Graph,
Yeah.
probability distribution plot, view probability. Okay. Now I am increasing the standard deviation to 5. Now what will happen to the area?
The curve will
reduce or
come.
Reduce.
Curve-
Area reduce, definitely reduce, sir.
Let us see. Let us see. The same situation. Only thing is standard deviation increase. Let us see a new curve.
Yes, sir.
Now
Yeah.
the chance of scoring between 75 and 85 has gone down. Because higher
Because we have
standard
taken the
deviation
value
indicates
5.
higher standard deviation indicates poor control over the students.
Yes, sir.
In business, poor control over the process.
Well said.
But overall, the curve has become, very wider. Can you see that, all of you? This curve is wider than the previous curve. Can you see that, all of you? Look at where is the 75 earlier. Look at where is the 75 now. This curve is wider. Can you see that, all of you?
Yes, sir. Yes, sir.
Only thing is,
Hmm.
I should simply show it in a bigger manner. That's all. So as the standard deviation increases, the curve will stretch outwards. The same 75 and 85 earlier, look at the 75, 80 earlier. Now what happened? The points are same. But look at your curve. Your curve stretched outwards. Can you see that, all of you?
Because variation is more.
Variation is more.
Deviation is
Variation is
yes,
more. Spread is more. That's the thing.
Sigma level will come down.
Now once the mean and standard deviation are known, you can find out the probability of any event. In order to calculate the probability, you need, two values always. You can't find out the probability for a single value. Always you should give two limits. Between 75 and 85, yes, you can find out. I want to know the probability for a student to get the pass mark. Will you be able to find out? The pass mark is 60. Tell me, how will you do it? How should we do it? Let us try. What is the chance for a student to pass the exam? Let me take you. So one of you, can you guide me? Where should I go?
Graph.
Probability distribution plot. Then
View probability.
View probability.
Okay.
Then okay. Then now it is a real case. When you are dealing with a real case, you must give the real mean value, real standard deviation.
Yes.
0, 1.
Can I keep the same standard deviation 5? Or you want me to you want me to take it to the original 2?
2. Okay.
2. Let us keep it
2.
original. Now what is the probability for a student to pass? Now what are we talking about?
Middle.
Left side, right side, or in between?
Both graphs.
Middle.
Okay. Both means what will be your lower value, x1?
X1 will be 65.
Pass mark is 60.
Okay.
Then what will be the maximum score?
100.
8.
But there is a problem in this approach. I'll tell you. Anyway, let me get the probability here. Now, what is the probability?
1.
1%.
1 means 100%. Almost, every student will pass. Your class is, very good. That's what you could understand. Now, let me show another method. A slight difference. Graph, probability distribution plot, view probability, okay, 80 and 2, shaded area. We are interested in finding out the probability of a student scoring 60 and above. 60 and above means it is right tail. Am I right?
Okay. Yes, sir.
Just to give 60, that's all. Anyway, the result is same. Result is same. Full probability. See, 1. 100%. All right?
Okay.
But it is shifted now.
What is shifted? No.
The
Original 75. Sorry, the class average is 80.
80.
Class standard deviation is 2. The process is like here. Earlier also it was here. Earlier also it is at the 8. The process is centered at 80. Earlier also standard deviation is 2. Only thing is, it is drawn like this. That's the difference. Nothing else. Understood?
Yes, sir.
And now you can find out what is the probability for a student to score between less than 45. What is the probability for a student to score between 85 and 90? Everything can be calculated, right? So you have no limit now.
But the standard deviation has to be, adjusted, or can we keep the standard deviation same?
Standard deviation is derived from the history. So far, you have conducted many exams. According to the many exams you have conducted, the class average is 80. The class standard deviation is 2. Our understanding about the entire class is 80 and 2. That will remain same. That is the basis for our decision making. All right, sir.
Okay.
If the class average and class standard deviation changes, then the whole scenario will be new. All right. So now we are moving on to the next question. Find the quartile 3 in a distribution where mean is 80, standard deviation is 2, and distribution is normal. What is your understanding about quartile 3?
This is
Left to side,
75%.
75 on left
75%.
side.
75%, sir.
Left side is 75 or right side is 75?
Left side is
Uh,
75.
Left side is 75, sir.
Left
Okay.
side is.
So right will be 25.
25, 25.
Now go to graph, go to probability distribution plot, view probability, give OK. Now make it standard because this is a standard case, isn't it?
Yeah.
Yes, sir.
Oh, sorry. Here also they have given
80, sir.
82.
80 to
Sorry.
yes, sir. 82.
Here also it is
yes.
given 80 and 2. So
Okay.
if the real values are given, use that. Now go to shaded area.
Middle. Now left.
Now if you can take left, you can also take right. Right
way. Sir, now we have to take right, sir.
Right
75%.
Wait. Right means you choose probability, choose right. What will be the right side probability now?
75%.
Area to the right of quartile 3.
125.
The right side area will
25,
be
yes, sir. Yes, sir.
25%.
25, sir.
Quartile 3 means the left side will be 75, right side will be 25. So you have to
25,
give
sorry.
0.25. Now the corresponding point, Minitab will throw. Can you see the point here now? What is the point?
81.35.
Same answer will come. Shall I do it by another method also?
Yeah.
Yes, sir.
Graph, probability distribution plot, view probability, okay, 82, shaded area. Now let me choose left tile. What should I give
75.
now?
75.
0.75.
That's all, you got the subject.
Yeah.
Now also the answer is, can you see the same answer?
Yeah.
81.35, sir.
And now we have to check whether that such an option is there in our question paper. If such an option is not there, question paper is wrong. You should come to that level. Don't always believe everything. Now answer option is there, right? So the right answer is
81.35.
81.35. All of you are with me on this question?
Yes.
Tell me now, will you be able to find out quartile 1? If I
Yes, sir.
change the question, the
Yes.
question is changed
Yes.
to quartile 1.
Yes.
Quartile
sir.
2.
Yes.
Very good. That's all. Now, see, just by learning one question, you are, gaining, your capability multifold. Any type of question can be answered. Now, according to central limit theorem, all of you, do you know central limit theorem?
Yes.
Yes, sir.
Yes, sir.
Central limit theorem is talking about sampling distribution.
Yes. Assembly.
Central limit theorem is not talking about population. Central limit theorem is not talking about your sample. Central limit theorem is talking about your sampling distribution. How the mean will get distributed. Central limit theorem is telling you mean will always get normally distributed. And the only requirement is sample size or the subgroup size should be adequate.
Right.
Now read the question and try to give the answer.
None, sir.
What is the answer?
None.
None.
No.
Okay. How about others?
Always correct.
Always correct. Okay. Any other option? Anybody to choose?
Which data
Two
is
more
the
options are there.
distribution of the mean will be normally distributed. Yes, sir. Always correct.
Okay. Tell
No,
me
sir,
what is that we understood
regardless of the
about?
population, actually, when the population goes up, then only it will be correct. The smaller the population, the things will not be right. So,
Sir, I'll make a point here. All of you, please, one more.
Conditionally correct.
One
I
more.
think
One,
most of the time it would not be correct.
Conditionally correct is the correct answer. I'll tell you. See, your population can be normal and non-normal. Am I right? Population can be normal, non-normal. Similarly, sample distribution can also be normal and non-normal. In all situations, the distribution of the sample means will remain normal. Only condition is subgroup size or the sample size must be adequate. Here, if you read the entire statement, they did not mention anything about the sample size. Can you see that? So that condition alone is missing. So having added that condition, the statement is correct.
Okay.
So conditionally correct. You don't have to worry about how the population is distributed. Just keep on, increasing your subgroup size gradually, and you will definitely be able to see a smooth bell curve, appearing in your curve. Right? That is the reason why most of the time we work with, sampling distribution for to predict our, to predict, the future. I mean, what is going to happen? What kind of result is going to come? We most of the time we look at the mean only. Am I correct?
Yes.
We
Yes,
are
sir.
trying to take decision only using mean, not by using single observation. If you are taking decision using a single observation, you are referring to sample distribution. If you take a decision using the mean value, you are referring to sampling distribution. Am I correct?
Yes.
Yes, sir. Yes, sir.
Siva sir, I have a clarification here. You were talking about population and sample, but at the same time, I remember one time you told the sample size when it is getting larger, it tend to follow the normal distribution.
Exactly. It
This
means
is what I remember.
it means sample means. The it stands for sample means. If you gradually increase your sample size, the sample means will tend to follow normality. This is exactly central limit theorem.
Yes, sir.
Clear?
Yep. Okay.
Now moving on. An extrusion die is used to produce aluminum rods. The diameter of the rod is a critical to quality characteristics. Specifications of the rods are 100 plus or minus 0.5 inch. So upper spec is 100.5, lower spec is 99.5. The process average is 100.31 and the standard deviation is 0.05. You have to compute CP.
Excel version 5. Version 5.
Excel version 5
Version
is
5.
the best
CP,
method.
CPK. CP, CPK.
I agree.
99.5. 100.5.
Very good. I will open that. I'll open that so that, Can you all see my sigma level calculator version 5 right now?
Not yet.
Oh, not yet? 1 second.
Now I can see Surya sir.
It's visible, right?
Yes, sir. He is visible.
Visible or not visible?
Now nothing
He
is
says
visible. The
Surya
black.
is visible.
Okay, sorry. So now,
Yeah,
it
now
should be
visible.
Now see, yes, sir.
Now go to CPCPK. See,
Yes,
I
sir.
am trying to simplify things for you. RK sir is trying to give you a deeper knowledge.
Yes, sir.
I am trying to give you an outer level knowledge. With outer level knowledge, you can penetrate well. So RK's template, you explore little later. Now one file, go to CPCPK. Now some values are given. I think the values are already fed properly. It has eased my job, right? So 100.5, 99.5,
99.5.
and the mean value is 100.31. Standard deviation is 0.05. You simply type all these values, 0.05, 0.05, and give an enter. Now what is the CP?
3.33.
3.333.
Just check whether 3.33 is there in your option. Is there your option? So answer is option D. Am I correct?
Yeah.
Now, desktops are being inspected to check whether the following components are functional. RAM, motherboard, screen, hard disk, Bluetooth, and memory slot. How many items you are checking?
6 items.
Six opportunities for a defect to happen in your laptop or in your desktop. Now, 1,000 laptops are inspected. I'm sorry, both words are used, right? 1,000 laptops are inspected. Now, the team has noticed 238 defects. Under this scenario, what will be your ZST? And we have to go to, see, in when
Version 5.
Yeah, when the
ZTM.
analytical questions are coming, better use the tools, right? And the tool we have given you is the sigma level calculator. Now I should go to
Discrete data, sir.
this
Sorry,
scenario.
sigma. Sorry, sir.
Discrete situation. Opportunity for error. Use this format, OFE, where you can type OFE. OFE is 6.
6.
Already typed.
Yes, sir. Yes,
And
sir.
number of laptops inspected is 1,000.
1,000, sir.
And then
238 defects.
number of defects is 238.
238.
Now, what is your EZST?
3.25.
This is very simple, isn't it now? This
Yes,
is
sir.
not at all a complicated case. No more a complex case.
Sir, one clarification. You put as number of defects is a 328 is a thing which
Good.
number of defects they have stated.
238, that is given.
Okay, okay. Right, sir, right.
238 is given and 1,000 units inspected. And opportunities for error is also understood as 6. And under the situation, EZST is 3.25. Now, the dimension of a particular part should be 125 and 130 mm. USL, LSL are given. An operator collected a sample of 100 parts. Process average and process variance are given. You need to compute ZLT and ZST. Can you understand the trick here?
1 second, sir. Process average. 1 second, sir. Process average.
Okay,
126.
okay. USL
126. Variance is 1.025. Yes, sir. Variance means standard deviation is square root of variance.
Square root of 0.25.
Instead
Yeah.
of giving standard deviation, variance is given. You have to
Yes, sir.
derive the standard deviation from it and then
Yes,
go to
sir.
the same sigma level calculator. Substitute
Yes,
the
sir.
USL, LSL.
Yes, sir.
Now substitute the average and standard deviation, not the variance.
DPMO version 5.
Right? I'll show that also.
DPMO version 5.
Hope all of you can see. Now the question is about ZST and data type is which data? Data type is continuous, right?
Sigma level calculator.
Yeah, go here, sigma level calculator. And I think mean is how much? 126?
1 second, sir. 1 second.
Mean is 126.
Yes,
Yes.
sir. Mean
And
is 126.
standard deviation should be square root of 0.25. Can you see my formula
sir.
here? Can you see
Yes,
my
sir.
formula
Yes.
here?
Yes, sir. Square root of. Yes, sir. Yes, sir.
Yes.
If I put straight away 0.25, I am wrong. Am I correct?
Yes, sir.
No, sir. It is variance. Automatically, we have to mention square root of 0.25.
And now under this situation, what is your EZST? What is the value you are seeing here?
Sir, LSL 125. Oh, okay. You computed. Okay.
I have given.
USL,
Now what is the
yes.
EZST?
Sigma
3.5.
ST is 3.5, sir.
So with the tools, our job becomes, very simple. But without the tools, it will be very, very difficult. So you must practice these tools. Now, a KPO processes reimbursement receipt for their customer. The time to process a refund claim is 30 minutes and the customer expects the invoices to be processed between 25 and 35 minutes. Every time a claim is made, the task must be completed between 25 minutes and 35 minutes. So this is the expectation customer has given and you have to compute the EZST and for which data file is also given. Refund. And now I will take you to the
30 minutes. Okay.
If you go to the Excel file, which I shared even today, you will find all the data files. You can refer these data files even during the exams. And see here, they're talking about refund, right? Let me see whether the refund is available here. Can you see refund here?
Yeah.
The data file is available. And with this data, you need to find out mean and you need to find out standard deviation, isn't it? So what is the formula for mean?
Average.
Average from here. Now mean is understood, right?
Yes.
Now standard deviation
Yes.
for the same. Now standard deviation also understood.
Yes.
Very easy, right? Once
Yes.
the data is given, you use Minitab or Excel or whatever, and then use this value. And we need to find out is it ST. Let us go to our, where should I go?
Sigma
level.
Sigma level. Correct.
Oh, these are the values I brought. Okay, mean and standard deviation. Now mean is equal to this one. Standard deviation is equal to this one.
Yes, sir.
And upper spec is 35.
25, sir.
Lower spec is 25. And now what is your ZST? What is your ZST?
0.97.
0.97.
0.97.
So we just go to the question, and is that 0.97 available?
Yes.
Yes. Yes.
Just tick it, that's all. I think this question we already seen. I'm just moving. Okay, in MSA, measurement system analysis, gauge study based on variance. Did we speak about gauge study based on variance as well as gauge study based on standard deviation? Every time you conduct a gauge R&R study, Minitab will generate two tables. First table based on variance. Second table based on standard deviation. The only advantage with the variance is there is an equation. Total variation is equal to measurement variation or the gauge R&R plus part-to-part variation. All of you, do you understand the meaning of all the term? Part-to-part variation, all of you know?
Yes.
And gauge variation?
Yes, sir.
Variation is gauge R&R.
Yeah.
So the gauge variation and the part-to-part variation, when I sum up, that will give me total variation.
Total variation, yes.
Now this equation will tally only in the variance table, not in the gauge R&R table. I mean, not in the standard deviation table. You can check, while going through the Minitab report. Now it is clearly mentioned, the study is based on variance. So the equation will tally. Now you are asked to find out the part-to-part variation. Gauge R&R is 0.59, total variation
Total variation,
is 0.622. Now what will you do?
Minus.
Total variation is equal to gauge
Minus.
R&R minus part-to-part variation.
0.3.
Total
Because-
variation equal to gauge R&R plus part-to-part. Now question is part-to-part. Part-to-part equal to total minus gauge R&R.
sir.
MSA plus process variation is equal to total variation. That is why
0.6 minus this 0.5.
590. Yeah.
Whatever
To
is the
get
value comes, that you have to choose. Can one of you do
Part.
it and then let me know the values? I don't want to do this.
0.032. 0.032.
That's all. All of you are with me on this question?
Yes.
Yes, sir.
A black belt is developing a failure mode and effect analysis in a software development unit. The following ratings were given for the failure mode due to a wrong coding. Severity of the failure is 3. Occurrence rate of the failure is 2. Detection rate is 9. What is the RPN in this case?
54. 54.
How do you get? How should
9
you?
in 9
9.
into 2 into 3. RPN is equal to severity.
Severity into occurrence into detection rating, right?
Sir, 1 second back, sir. No, you just missed it. Can you repeat, please?
No, you just multiply the severity rank, occurrence rank, and detection rank. All the three you multiply. That is called RPN. What does RPN stand for? Risk priority number. What is the prescribed value? Industry standard is it should be less than 100.
100.
Some companies they keep 120, 110. Yes.
Sir, risk priority number, sir.
Risk priority number.
Oh, right.
It should be less than 100. Anyway, in this case, they are just asking us about the RPN, which is 54, which is nothing but product of all the three numbers. Now, find the sample size for a one sample G test given the following. G test is meant for validating the difference in average. Am I correct?
Yes, sir.
So the difference in the average is 0.5. G test means population standard deviation should be known. So population standard deviation is 0.75. Power of the test is 0.95. Confidence level 0.95. What is the minimum sample size? So that you can validate this difference. All of you understand the scenario? What should be the minimum sample size you should have so that people can believe you? Yes, there is a difference in the average of 0.5. I'll tell you, there is a way, there is a feature in Minitab. That also I'll show you. Where is the Minitab? Yes, it is here. Now go to stat. Can you see power and sample size?
Yes.
Yes, sir.
Go to power and sample size. Now they are talking about the scenario is one sample G-test.
One sample.
Now the sample size, I don't know. I will leave it blank. The difference in the mean is how much?
0.5.
0.5. What is the power you want?
Power
95.
test 0.95, sir.
Okay. Then the standard deviation, how much it is given? 0.75.
0.75, yes, sir.
Go to option. And okay, it is two-tailed. And then significance level is 0.05. Why should I give
Yes.
significance level 0.05? That corresponds to a confidence level of
0.95, sir.
95%.
Yes,
So
sir.
for this condition, I'm giving okay. I'm giving okay. Now Minitab has developed the power curve for me. Can you all see that?
30.
Whenever you are in a
30.
scenario where you want to validate a difference in the average of just 0.5, your sample size should at least be 30. Understand?
Yes, sir.
If 30 samples taken leads to a difference in the mean of 0.5, yes, at 95% confidence level, it can be accepted. The difference can be considered a difference. Difference can be considered significant. Right? Suppose if you perform the same test with lesser sample, you will see your p-value going more than 0.05. Am I correct? That is what we did, isn't it? In all the G-tests, we always
Yes, sir,
look
sir.
for a p-value of less than 0.05. Now we are coming in the reverse direction. To generate a minimum p-value of 0.05, our sample size should be minimum of
30.
So this way, you can be optimistic in terms of sample size. What is exactly required? You can do it. All of you understand the purpose here?
Yes.
Yes, sir. Yes, sir.
And this problem, you remember, I already discussed, right? And there is a hospital. There are 4 laboratories. And here the performance is measured using the turnaround time. And you need to study 4 laboratory and you wanted to conclude whether one of the laboratory is performing significantly different from the others. What is the test you need to do?
Lab
ANOVA.
data.
ANOVA.
ANOVA.
Turnaround time is a continuous data. Go to ANOVA, go to Minitab, conduct ANOVA, and the same lab time data is available in our Excel sheet. It will also be, provided in the exam window. Whichever way you are comfortable, you can use it. So that's why I keep this Excel file in your site. And then you can study it, you can conduct the ANOVA and see whether there is a significance or not, right? And then you can answer. Now, for a particular hypothesis testing, alpha equal to 0.05, beta equal to 0.1. What is the power of this test?
90%. 0.9.
All of you understand? 90%, 0.9 is correct. Because beta is given as 0.1. So power of the test is 0.9. For the same test, alpha 0.05. What is the confidence level?
95%.
95.
0.95, sir.
Hope all of you are comfortable. Am I right?
Yes, yes.
We have discussed this many, many times. If the correlation coefficient is 0.9, you all remember correlation coefficient, Pearson correlation coefficient, small r.
Yeah.
Yeah.
R square, sir.
If the correlation coefficient is 0.9, the percentage of variation in the response variable explained by the variation in the explanatory variable, which is your x. What is the percentage of variation your x can explain?
90.
D, sir, 81.
81 is the correct answer. How are you telling?
1
R
point.
square. R is equal to
R
9.
square. You need coefficient of
Yeah, yeah.
determination to
Okay,
comment about the influence.
Okay, 9, yeah, 81. Okay.
The variation in my y is explained by the variation in the x to the extent of 81%. All right.
Yes.
So we are using R square here. R is 0.9. R square is 0.81, which is mentioned as 81%. The coefficient of correlation between u equal to x and v equal to minus x.
0. Sorry, -1.
-1.
Suppose x equal to 0, what will be the value of u? Suppose x equal to 0, what will be the value of u? U will be 0, right? Because x is 0.
1 plus 1 minus 1. It varies between that. Yeah, 0.
Again, v will also be 0. So you know the values of u for a particular value of x. Now I am saying x equal to 1. I am saying x equal to 1. I am increasing the x from 0 to 1. Now what happens to u? U also,
Plus or minus 1.
u also increases from 0 to 1. U increases from 0 to 1. Can you see your u going up? When x is increased from 0 to 1, u is going up. Am I correct?
Yes, sir. V is decreasing.
But coming to v,
It is
when I increase
decreasing
the x
-1.
from 0 to 1, v is going down. Can you see that?
Yes, sir. -1 is the
So
value.
now
Correct, sir.
that means as the u is going up, v is going down. Now what is the coefficient of correlation between u and v?
-1. Sir.
-1. All of you understand?
Yes, sir. Yes, sir. Yes, sir.
Right?
Well, sir.
We studied between x and y, but now it is, it is narrated between u and v. The rules are common, right? Between x and y or u and v, it is common. In two-way ANOVA, with one factor at 4 level and the other factor at 3 level, without replication, what is the total degree of freedom?
4 3s are 12, sir.
11.
In order to comment about total degree of freedom, you should first of all calculate total number of experiments.
Yeah, 12 experiments.
How are you saying 12 experiment?
4 into 3.
Level of the first factor multiplied by level of the
Level
second
of the
factor.
third.
And
Super.
clearly there is no replication.
Yes, sir.
No replication, right? So 12 is correct. 12 minus 1 is?
11.
11.
So the answer is here.
Sorry, sir. 11 is the answer. Sorry, sir. 11 is the answer.
11 is the answer. 11 is here.
Sorry, n minus 1. Sorry.
Yes, correct. Now we are moving on. In one way ANOVA, with 4 levels of a factor without replication, what will be the total degree of freedom?
3.
4 minus 1, 3, sir.
3.
Hope all of you understand this, right?
Yes,
Always
yes,
you should, in order to comment about total degree of freedom, you should know total number of experiments. In this case, total number of experiments is 4.
4.
So 4 minus 1 is 3. A process excellence team in a bank inspects transaction. A process excellence team in a bank is inspecting the transaction. There are several opportunities for error in each transaction. In every transaction, there are 7 opportunities. Account number is mentioned wrongly, transaction will be a failure. Do you understand? The bank IFSC code mentioned wrongly, the transaction is a failure. There are 7 opportunities. Now 100 transactions are inspected every day and the number of errors is recorded to see that, whether the process is under control or not. Now, which control chart will you use now to study and keep the process in statistical control?
U chart. U chart.
This is different.
Option A.
Option A. Option A. Yes, somebody chose P chart.
No.
And
Yes,
Bala sir
This
said
is U
U
chart.
chart.
Because
This is
the
U
7
chart.
opportunities
T chart,
are
sir.
regular.
No,
Regular.
my point is that
Defects.
the data is more. That is, recordings are more.
Sir,
So
NP
no,
chart.
no.
See.
larger
This
the
is
thing
U
is
chart.
No, NP chart.
U chart.
So far, the correct answer has not come.
See, NP chart.
No, I think
I'll now tell you. What are you monitoring? Are you monitoring the defects or the percentage defective? What are you monitoring here? What are you trying to monitor?
This is defect.
Sir, this is C chart, sir.
Ah.
Because 100 transactions are inspected every day.
The number of errors are recorded. Number of errors means number of defects. Number of defect is recorded. So you are not on the defective side. You are on the defect side. Now your option is restricted to C and U. Can you see that, all of you?
See.
Yes, sir.
And now every day you are checking exactly 100 transaction.
Yeah.
Yes, sir.
There can be many transactions, but you are checking only 100. Your sample size is fixed. Now you have to use the C chart. See, control chart, don't get confused. Just think, with the basics, that's all.
It's not variable.
One side is defect, other side is defective.
Effective.
Now let us take another case. An inspection process checked parts produced for defectives. The total number of parts produced shift-wise and the number of defectives were recorded for 24 shifts. Which type of control chart would you use to study the process variation?
Defectives. No several part.
What produced?
Each.
This defective would be.
Come on.
Very NP chart.
What is the requirement to go for an NP chart?
Defectives.
Unit per defectives.
Defective.
chart.
Very simple.
Defect.
Sample size must be constant.
Yes. Yes.
Now,
NP chart.
what is the sample size here? The units produced itself is the sample size. Can you see that, all of you?
Yes.
Yes, sir.
Do you think units produced will be constant always? And it is
Yes,
not
sir.
given, it is not mentioned as constant.
Yes, sir.
So every shift, there can be, different number of units produced. So better to go for is,
P
better to go for is
P chart.
P chart.
P chart, right? Because we go for NP chart only when the sample size is constant. Very
Constant.
simple. That's the guideline.
Yeah, okay.
Which of the
Unit
following
varies.
is not included in the list of 7 waste?
Okay.
No proactive risk analysis.
No proactive risk analysis.
Correct answer.
Yeah. Yeah.
Which of the following technique dramatically shortens your changeover time?
SMED.
Single.
One
yes
second,
or
sir.
no?
Which of the following techniques dramatically shorten change over time? Single minute exchange of dies.
Very good. External
Yes, sir. D, sir.
activity, internal activity, and try to convert some of the
Single
internal
injection.
into external,
Single.
and then try to minimize the cycle time of the internal activities, and your changeover time will be reduced. So answer is SMED. A system that delivers products or services at the correct time and in the correct quantity is referred to as
Just
Time.
time.
Not time.
Just in time.
Just in time.
Doctor time.
Sorry, just in time. Just in time.
just in time. Just in time. That's all. Thank you very much. You all did well.